in February 28th notes. And so if this quantity here is greater than 1, so if this quantity right here is greater than 1, that means that the Q is less than the KSP or the KEQ. And so delta G of dissociation is going to be less than 1 and the dilution occurs. And so you can walk this through. If KSP equals 1, so if KSP over Q, this quantity is 1 right here, that means that Q equals KSP. And so the log of 1 is 0, and so delta G dissociation is going to be 0. So that means we're at equilibrium. If this quantity KSP divided by Q is less than 1, it tells you that Q is greater than KSP, and so it tells you that delta G dissociation is greater than 1, and the reverse reaction occurs. And so whether you have a negative delta G tells you this reaction is going to go this way, or a positive delta G tells you the reaction is going to go this way, you can keep track of what's happening with this idea of KSP over Q. So this is a little bit complicated for this reaction, but this is the full story. If you just stick with this. If you just stick with this key equation right here, and this key equation right here, you can always tell me what the equilibrium constant is and what the delta G of reaction is. Yeah?
Is it always true that if the equilibrium constant is greater than 1, then that means it's going to be favorable, or like it's going to be favorable, and if it's less than 1, it's going to be not favorable?
Yeah, that's always true. So this comes from, let me just make sure the camera's still recording here. Good? So what equation might we want to use to figure that out? Whether KEQ is greater than 1 or less than 1.
Delta G equation?
Yeah. Well, we have lots of delta G equations. Delta G0 is negative RT ln KEQ, right? If this is 1, KEQ is 1, ln of 1 is?
0.
That's 0. Defines equilibrium. If KEQ is greater than 1, what's ln of a number greater than 1? Positive number. If this is a positive number, this whole thing is negative, and so if delta G0 is negative, it means the reaction is going to proceed. So we have reactants, and they go to products. So negative delta G means we're going to go this way, and that's also KEQ greater than 1, going to go that way. These are the same thing. But if we have positive delta G, the reaction is going to go this way, or we're going to favor reactants, and so our KEQ is going to be less than 1 in this case. So this equation as written, we have reactants on this side, products on this side. That's fine. So let's say we have H2 plus N2 goes to NH3. Okay. The delta G of reaction for this is positive, negative, or 0? The delta G0, sorry. What was it from the homework? Positive, right? You mix hydrogen and nitrogen, the delta G0 is positive. For this is written. What if I wrote 2NH3 goes to 3H2 plus 1N2? What's the delta G0 for this reaction? Negative. What if the KEQ for this reaction on top is 1 times 10 to the minus 5? What's the KEQ for this reaction? 1 1 over 1 times 10 to the minus 5. So whether you say favoring products or favoring reactants with positive or negative delta G, or you just write two separate reactions. This is the forward direction, as written. This is the reverse reaction, as written here. You can figure out what's going on between just positive or negative delta G and the KEQ. Does that work? Yeah? There were other hands up? Yeah.
I was thinking like, so, in that case, if KEQ is 1, then delta G 0 would be 0. Delta G 0 would be 0. But that doesn't necessarily mean that delta G is 0, right? Because then you still have to add the other one. Like the equation for delta G you said was delta G 0 plus RT ln Q.
Yeah, okay.
You know what I'm saying? So like I didn't know.
Yep, no, I gotcha. So this is relating delta G0 to the equilibrium constant, right?
Right.
Set in stone. We also have delta G of any reaction, not at equilibrium, is delta G0 plus RT ln Q. This is not the equilibrium constant. This is the reaction quotient. So only at equilibrium, only when delta G of the reaction is 0, Q equals KEQ. Otherwise, you can always calculate delta G0 from the tables or something like that. If you know the concentrations, you can always come up with an expression for the reaction quotient, and then you can calculate delta G of the reaction from that.
Okay.
So if I say you are at equilibrium, this is the expression. If I say, are you at equilibrium, you might want to use this one. Or you might want to compare delta G0 and KEQ. So let's say if I give you let me give you this reaction right here, since I have it written on the board. So this is reversible. So I say we run this reaction and the pressure of hydrogen is 0.6 atm. The pressure of nitrogen is 0.3 atm. And the pressure of NH3 is 0.1 atm. And the question is this system at equilibrium? Yes or no? How do we figure that out? So what equation do we know about equilibrium? Or what's a really easy way to figure it out? If you had what one number, how would you know?
Find Q. If we had the concentration, the equilibrium constant.
Great answer. So at equilibrium, Q equals KEQ, right? And so we can say the concentration of NH3 squared over concentration of H2 cubed times concentration of N2, and we could just put in the pressures, right? Yeah?
Which phases do you not include? Like I know obviously they're all there, but
These are all gases.
Yeah.
That's right.
but for like in general. is
No solids and no solvents.
it- Okay.
So like water is a solvent for an acid, right? You don't include water. Or sodium chloride or sodium bicarbonate that's precipitated, you don't include that. So no solids and no solvents.
Okay.
And solvents will be water, things like that. Solids should be marked with an S. You include anything in the gas phase, anything in the aqueous phase if it's an ion, something like that, that's all included in the reaction quotient.
Okay.
Okay. So we could figure this out, right? We just say, okay, NH3 is 0.1 squared times hydrogen 0.6 cubed and 2. Does this equal Ke cubed? Piece of cake. So if you know the equilibrium constant. What if you don't know the equilibrium constant?
You use the delta G equation?
You
The
could-
one that uses the RT ln Q.
You could use delta G0 is negative RT ln KEQ, right? Maybe you have a table to find delta G0 for this reaction so you can get to the equilibrium constant. Then you can do this. Or if you have delta G of the reaction is delta G0 plus RT ln Q. We know what Q is, we just calculated it. We still need delta G0, you can't get around that. So we could use this equation, delta G0 RT ln Q, to figure out if we're at equilibrium, what's this value going to be? 0. So this whole business of the reaction quotient and whether the reaction quotient equals the equilibrium constant is a really important idea, along with these two equations, to figure out if you're at equilibrium or not. So when I say any question on the exam or any question on the homework that has the word equilibrium in it, you're thinking delta G, KEQ, delta G0, and reaction quotient. Those are the 4 important ingredients. These equations aren't complicated, right? There's only 1, 2, 3 unknowns. 2 unknowns in this one. So, but anything that has to do with equilibrium, you need to be thinking these sorts of ideas. Yeah. Oh.
So I wonder if there are some, if this reaction is endothermic or exothermic, because I heard there is the one reaction that it absorbs a lot of heat, but it is exothermic.
Yeah, that's not true. So when you're talking,
I mean this reaction absorbed a lot of energy at first, but it is exothermic.
so let's talk about that. Okay. Is everyone good on equilibrium?